Hey guys, what's up? Hope you're all doing well. So, this is the first video of the thyroid series. You'll get its continuation on thyroid related diseases in the coming up videos. So let's start today's video without any delay.
Click on Zombie Apocalypse.
So, let's start from the brain. There are two structures known as hypothalamus and the pituitary in the center of the brain. The pituitary is connected to hypothalamus through stalk. It consists of two parts. The anterior part known as the anterior pituitary or the adenohypophysis. The posterior part known as posterior pituitary or the neurohypophysis. The hypothalamus secretes a hormone known as thyroid-releasing hormone, which reaches the anterior pituitary through capillary plexus. And the anterior pituitary, in response to thyroid-releasing hormone, secretes a hormone into the bloodstream known as thyroid-stimulating hormone, TSH. The thyroid-stimulating hormone reaches the thyroid gland and makes it to secrete T3 and T4. Coming on to thyroid. It's a head-shaped gland present on trachea or the windpipe. It consists of numerous functioning cells known as the follicular cells. These cells are arranged in a circular pattern with a center space known as the colloid. This colloid is a liquid space and it's a tight space. Let's take a single follicular cell. The thyroid hormone synthesis mainly requires iodine initially. The iodine is entered into the follicle cell by transport mechanism known as sodium iodine symport. It allows two sodium and a single iodine. This iodine is transported into the colloid where it is converted to iodide with an enzyme known as thyroid peroxidase by a process known as oxidation. The rough endoplasmic reticulum of the follicular cell secretes a protein known as thyroglobulin, which is also secreted into the colloid. Where the iodide attaches to thyroglobulin. This iodide binds to thyroglobulin either once or twice. If it binds once, it's known as monoiodotyrosine, and if it binds twice, it is known as diiodotyrosine. This process is known as organification. The next step is coupling. This MIT and DIT adds up to each other, either MIT plus DIT forming T3 and DIT plus DIT forming T4. The form T3 and T4 are still connected to the thyroglobulin. So what happens is these again enter into the follicular cells where the T3 and the T4 are detached from the thyroglobulin by a process known as proteolysis, which is protein cutting. Now this T3 and T4 exits out the follicular cells where the T4 is converted to T3 by the process known as deiodination. This entire process of thyroid synthesis takes place in a negative feedback mechanism from the hypothalamus to the thyroid gland via pituitary. Hope you all have liked the video. Please do share if you find this informative. See you in the next video.